Okay. So 7.1 introduced the standard normal curve. Um, and there's a summary that I need you to really understand on the top of page 295. And it was really 3 bullet points, or it is bullet points. It says a probability density curve represents the probability distribution of a continuous variable. The area under the curve is always equal to 1. And the area under the curve between two values, A and B, has two interpretations. So one is the proportion of the population whose values are between A and B. It is also the probability that a randomly selected individual will have a value between A and B. So I would know that summary. So for the first bullet, know the summary. And it might be regurgitating it on a test. It might also be explaining it, right? Or using it in context with a question. But that was really before the normal aspect. The first thing the book talked about with the normal curve was on page 297. So wait, I'll put some pages on here. Page 295 was just the summary for probability density curves. That could be any curve. But then on the top of page 297, it goes over the properties of the normal distribution. Properties of, I'm going to just put normal here so I don't have to write as much. Properties of normal, it's on the top of page 297. And your book goes over 4 main properties. The fourth one is just an empirical rule. The first 3 are more like definitions where, the distribution has one mode, it's symmetric around the mode. The mean and median of a normal distribution are both equal to the mode, so they all sit on top of each other. And then the fourth talks about the empirical rule. So I would know the empirical rule. It's built into that property. The empirical rule for approximating. What is your book? It says empirical rule. Understand the empirical rule. I believe we've talked about it already on another test, or at least in another section, but it's going to be more detailed questions because this is the normal section. So, I'll give you an example and I'll give you a standard deviation. It'll be, okay, well, using the empirical rule, what's the probability between these two values or above this value? But I will make sure to write the empirical rule when I say that, because we know how to get the actual, areas now, because it pops up in 7, 2, 3, and 4. But if I mention empirical rule, I want you to use that approximation that the empirical rule goes over. Yeah, and then it's just finding areas under a curve. Well, this was finding areas under the standard normal. Under standard normal, which we use the calculator. Your book, if you read the book, it used a table. Mucho easier with the calculator, right? So finding areas under the curve, under the standard normal curve, I'm going to say calculator. And we went over that extensively in the lessons. So if you go back and watch the videos, you'll see that over and over and over again. Where does it talk about finding the z-score? I thought that was.
I think it goes into that in 1.2 or 7.2.
7.2. Oh, okay.
Yeah, 7.2.
Okay. Oh, also, you find the areas on the curve, and then the inverse aspect too, which is on the page 301, and it's where you actually find a z-score given an area. And it's on 301 and 301 to 303. And I remember that was the one that I actually skipped over in the lecture. I had to hit it the next lecture. So I think if you go into 7.2, you'll actually see I talked about this at the beginning of 7.2. But it's the opposite. And again, use a calculator. Your book even goes over how to use the calculator. I think for all these, actually. So that's nice. Now, questions that, okay, so like knowing the summary and the properties of the normal and the empirical rule, well, empirical rule will have questions, but this is just the definition type stuff. The bottom 3 here, though, are going to be from the homework. So good examples of that would be, let's find some for the empirical rule first. See, your book doesn't even go over the empirical rule in this section. I think it was in a different section. When was it? Huh. I swear it went over. Hold on, guys. No, this has been a long semester. Too long.
No kidding.
Yeah. Empirical rule. Give me just a minute. Yeah, 121. Okay, we totally went over this before. It's been on another test. So you know what? It's not in your homework in this section because it was on another test. So if it's not in your homework, I'm not going to ask you to do it. And it's not in your homework. So don't worry about this. Now, I will say it's going to be on the final because it was already on another test, but do not worry about the empirical rule on this test. I'm going to use this later. I haven't made the test yet. I've been busy, and so I'm going to make my test today based off this, what we're going over right now. So don't worry about the empirical rule, but I'm going to give you some homework on finding the areas under the standard normal and the z-score. It'll have to be more written, but oh well. Yeah, like number 23. This is on page 307. I'm going to just choose some that I think I would mimic if I was going to write when I write the test. Number 23. Number 25, because that's to the left and to the right. And then we've got to do in between. And then on the outside. So 27 and 29. Those are all four different. If you look at those, I'm going to keep going. I don't know why I put parentheses there. And then the opposite, when we want to find the z-score, imagine that is not there. We'll put a parenthesis. Finding the z-score is like 31. Okay, left. So let's do one to the right. 35. Yeah, 31 and 35. That's like the z-score question from right here. Okay, so these are all good questions that'll mimic how I'm going to ask it on the test. Okay, so if you know how to do those, you'll be able to find. And then just know the summary about the probability density curves and know the properties of the normal. Okay, know those properties. And again, you don't have to memorize it. Really, it's going to be more about knowing it in context than anything else, because you'll have your notes. Paper. Give me 2 seconds, guys. That was 7.1. Let's go to 7.2 now. I know this is where Lori had questions. 7.2 was on the applications of the normal distribution. And it started with the z-score. Okay, great. Yeah. So, and this is like the definition aspect of the z-score. I want you to be able to find the z-score and interpret. Okay, so when I say interpret, I mean, if I know my z-score is 1.5, that means I'm 1.5 standard deviations from the mean, right? That's what I'm looking for. So I need you to find the z-score and interpret it. Know the properties of the z-score because they'll help you with interpreting, okay? It's on page 308. Okay. And your book talks about rounding it. The z-scores in the table, so we don't use the table, are expressed in 2 decimal places. For this reason, when converting normal values to z-scores, we will round off the z-scores to 2 decimal places. That's not necessarily true when I make this test, but I want you to know I'm not going to make the answer, like, there's an issue with rounding, and I know we talked about it in the lectures. There's an issue with rounding when it comes to these sections, because if you use a chart, you have to round. We're using calculators, so it's a little easier to not have to round. Just realize I'm not going to make 2 answers really close together because of that. So if your answer, say your answer comes out to and I'm not saying just for z-scores, this could be anything. But let's say your answer comes out to 1.20569 in the calculator. And, option A is z equals 1.20. And you're like, hey, wait a minute, that should round up. It shouldn't round down. But realize this is going to be the answer. Because like B is going to be maybe negative 1.20. C is going to be z equals 0. And D is going to be like z equals 2.9. I'm not going to make one that's so close where you're having to debate which one to choose. Okay. So just realize that. You go, okay, I know that didn't round properly for what I got, but that has to be the answer because it's the closest. Okay. And that's just a goofy thing that has to do with rounding in this section and how they really kind of taught this without the calculator, which is not bad. It's not a bad thing. It just makes it a lot more difficult to teach. And it doesn't help in the end because the goal of stats is interpretation, not algebra. Okay. So yeah, you got to be able to find the z-score, got to be able to interpret it, know the properties of the z-score. And then we get to finding the areas under the curve. So not just the standard normal, any normal. Okay. So in the 7.1, it was only areas under the standard normal. Now it's just finding areas under the normal. Under the normal and interpret. So this would be like, okay, I know that the area under the, from, I think we did a lot of height questions, but like if I knew the average height of males was, 5'10", and I want to know, well, what's the area since the average height of males is normally distributed? What's the height of the area between, 5'8" and 6'2"? Well, then you find out, let's say it's 0.23. Well, that's the answer, right? But then the interpretation would be, 23% of the or proportion of adult males have heights between 5, whatever it was I said, like 5'8" and 6'2" or 5'10" and 6'2". So it's the interpreting aspect as well to that. So that's probably a good 2-question type question where I ask you to find the area and then ask you to interpret. And from the properties from the last section, like there's a few different ways to interpret it that are correct. You could say the proportion, or I think they said the probability, right? And either one's fine, but I've got to make sure you grasp that concept where it's either the proportion of the population of males, are between these two values, or the probability that I randomly select a male between those two values is, 0.23. So either one's fine, but I just need to know that you know how to interpret that. Okay. Find an area under a curve. Yeah, and I'll tell you, we use the calculator extensively through this. This was a calculator thing. This was not a table thing. It makes it mucho harder to do. Yeah. No, okay. Hold on. Which question did you have on this 7.2, Lori?
Okay, one of them was number 29.
Okay, so check your blood pressure. Centers for CDC and Prevention reported the diagnostic blood pressures of adults. Oh, okay. In the US are approximately normally distributed. Find the 30th percentile. So what they're actually...
Okay, I got the A and the B. I understand the percentiles, but it's finding what to put in the calculator for the third, to get the third quartile.
Well, the third quartile is 75% of the data. So let's make sure we get this right. So tell me what you did, and I'm going to try to mimic it.
Well, I went into, where was I? Stat.
Okay.
Edit. But that's where I don't know what to put in.
Well, we wouldn't put in a list. Hold on. No, that's not going to be it. So stat. I don't think it's calc. No, I think we need to do distributions. But would this not be an inverse normal? Hold on. I don't know why I don't have all the answers. You have all the answers, right? Like you got the answer for...
Yeah, the answer for number 29 paper.
Hold on. What's the answer for part A for the 30th percentile?
Oh, part A is 75.31.
Okay, hold on. I'm gonna write that down. Because I think it's an inverse normal question, and I could be completely wrong. But
And B is 4.86.
okay.
And we need to find the C.
Oh, I got you. Give me 1 second. I think because I don't think we did one of these in the lecture, so I'm glad you asked. Yeah, there it is. Okay, so what it's asking you, this is actually an inverse normal. So hold on, let me draw.
Okay, but the answer for C, which is in the back of the book, is 87.18.
Okay, yeah, hold on. Let me just explain where we're getting this from first, and then I'll get to C. That's not a big deal. So yeah. What we're saying is, remember, it's giving us the percent, right? And we're wanting the Z value, but it's not the Z value now. It's the actual value. So if we looked at like 29, just to kind of go over this, because it's a really good question that I don't think I went over in class. So if we went over 29 real fast, the CDC reported that diastolic blood pressures for adult women in the U.S. are approximately normally distributed, the mean of 80.5 and standard deviation 9.9. Find the 30th percentile. Now, 30th percentile means our cutoff scores here. We know in the middle is 50th percentile, right? So we want 0.30 right there. What is this value that gives us that? Okay, we want, and it's not the Z value, it's actually considered an X value. What's the X value? Was it the pressure? What is it blood pressure? Blood pressure, yeah. What's the blood pressure that's in the 30th percentile? And so what you do is you actually use inverse normal for this. And we're going to type in what we know. They tell us the mean for blood pressure is 80.5, or for one part of the blood pressure, the diastolic. And then the standard deviation is 9.9.
9.9.
So if we go to distributions, you'll see the third option is inverse normal. And I already put this in, but so the area is the area to the left. And I remember, was it yours that actually said left or right, Lori? I think.
Yeah.
Yeah. If you have
I have left, center, and right.
Yeah, it's kind of nice. So if you have a newer one, it'll ask you if it's to the left or right. If you haven't, this isn't even an older one, but if you have an older calculator, it assumes it's to the left. So I'm going to do 0.3 and then 80.5 because that's the mean that we found, or they told us, and 9.9 for the standard deviation. Paste it, hit enter, boom, 75.31. So that means the 30th percentile. So I can assume that 30% of women have a diastolic blood pressure less than 75.31. Okay. Or the proportion of women that have less than a diastolic blood pressure of 75.31 is 30%. Okay. Now, part C, though, which is what Laura's asking, it's asking about the third quartile. Now, remember, the third quartile is the 75th percentile. You had to remember that, right? If we broke this down, I'm trying to leave some room right here to write. But if we broke down quartiles, here's our quartiles. We had quartile 1, quartile 2, and quartile 3. Oh, catch out there. So quartile 1, only 25% of our data is less than quartile 1, right? And it's just broken down in blocks. So these are all 25% blocks. So quartile 3, 75% of our data is to the left of quartile 3. So let me use another color so I don't have to rewrite here. So if I wanted the 75th percentile, all this needs to be 0.75. So instead of 30, I'm going to use 0.75, or instead of 0.30, I'm going to use 0.75. 87.17. Was that right? 87.18?
87.18.
Yep, there it is. That's it. So
okay.
So if you see quartile, it means what, it goes by. So if you wanted like the first quartile, it would be 25%, right? The second quartile is 50%. Third quartile is 75%.
So that, okay. Yeah, because I don't remember going over that.
I don't think we went over this question. We've gone over quartiles before though, because we found quartiles.
Yeah, and that's when we did the list.
Yes. Yeah.
That's where I was trying to figure out how to do it.
I got you.
Through the list, and it's like, this ain't coming out right.
Yeah. So I'm going to put that on here now. So find the value, which is the percentile, given. You'll have to be given the mu and the standard deviation. And I'll put some of those in the homework. That's not a big deal. But for homework, what I would look at, and I'm going to steal some homework questions, I should kind of show you some ones to focus on. And I would still look, like those understanding the concept questions are really good in your book. I'm glad you put those in there. Those are good questions.
Okay.
I'm listening. 17. This is page 317.
Okay, number 17.
Number 17 is just a good basic kind of question where we're not dealing with z-scores now, we're dealing with actual scores, right?
Mm-hmm. Yeah, I figured all that out. It's just the quartiles, figuring how to do that one in the calculator is what got me.
I got you. Yeah, 17, 19, 21, 23. Yeah, I mean, in 25, those are good. Hold on, and let's see if we can find a good real world question that I like. Oh, you know what? I like 31 because it's about fishing. Big chickens. That sounds funny. And 39. Those are too good. 39. Well, I'm going to keep going. They do some really good, real world kind of examples here. But yeah, 43 is a good one for quality assurance stuff. Yeah, well, those are good. Those are three good real life questions right there. But they're all about finding the area under it or finding the percentile given it. Those are good questions.
There was another one in the homework that I couldn't figure out.
Yeah, which one was it?
Find that. I'm gonna try to find the page now.
Yeah.
It was number 51.
Number 51. 7.2?
Yeah. Because we're supposed to go up to 55, I think.
Okay. Extending the concepts. Let's see. Why did I give you these? Tall men. Heights of men in a certain city are normally distributed with a mean of 70 inches. Right? And 16% of the men are more than 73 inches. Was it 73 inches tall? What percent of men are between 67 and 70 inches tall? Okay, this is kind of neat. Yeah. I see. This is kind of goofy, but you don't need a calculator. So let's think about this. we've got a normally distributed. Does it even say it's normally? Yeah, it says it's normally distributed. And we know the mean's 70, so 70 inches is right here, right? And 16% are more than 73 inches. So I'm going to say 73 inches is here. Now, here's what we know. We know this gap right there is 0.16, right? Now it says what percent are between 67 and 70? Well, okay. What's the reason we can solve this one, Lori, is because everything is symmetric. Notice that this 67 is 3 inches shorter and that 73 is 3 inches taller. So these distances are the exact same, which means the proportions are the exact same. Okay?
Okay.
So that means that this tail right here is 0.16 as well.
Okay.
Now, I'm gonna do a little math here. Oh, not 50. If we know 100%, or we'll say 1.00 lies underneath everything, right? And we're going to subtract off 0.16 and 0.16 to find out this gap in between. So I'm going to be lazy. I think it's like 60 something clear. 1 minus 0.16 minus 0.16. 0.68. So I know the gap, like in here, I'll do like this area here. That area right there is 0.68, right? That makes sense?
Okay, what'd you put in the calculator?
Oh, I just did 1 minus 0.16 minus 0.16. I got lazy. Because we know it's 1 underneath here, right? That's one of the rules about the normal. And I subtracted off the 2 tails. Now, look, everything is symmetric. So that means if I come through here and I slice this thing in half, these 2 areas would be the same. This would be the same as, let me get another marker, as this area, right?
Right.
So if I know it's 0.68 for both these areas, I just divide that by 2, which turns out to be 0.34. So 0.34 is going to be our answer there. And think about this. We know the 4 sections here. So 0.16 plus 0.34 plus 0.34 plus 0.16 is going to add up to 1. Yeah, so that's right. So I like that question. It's a good. That is a good extending the concept question. That's a great way to kind of phrase that.
Okay, yeah, because me personally, I have a hard time with word problems.
Yeah, and this stats is
always have.
Yeah.
Always will.
Was there another one from that section?
No, I stopped right there. I didn't do 52 through 55.
I wouldn't, Lori, for this test, don't worry about it. If you're just studying for the test, focus on those ones I told you to focus on.
Okay. That works.
Deal. Okay, let's go to 7.
I won't complain.
Yeah. Let's go to 7.3. 7.3, which is on sampling distributions, which are a little different. And because of that, we have to really kind of grasp why they're different and how to find their standard deviation is different. So this is 7.3. You need to understand that summary on page 231. Summary on page 231. And it goes over how, we're talking about the average of the averages. I know it sounds goofy, but it's the mean of the samples. Is always equal to the mean, the population mean. But then the standard deviation of the samples is found a little differently, and it talks about that in that summary on page 231, and you have to find it. So not only that, so you have to know how to find the mean. Now, and I'm going to tell you, I don't know how to write this in Blackboard. So it's going to come across as finding the mean of the samples. How do they write it? Sampling distribution. Yeah, find the mean of the sampling distribution. So it's going to be more words, in Blackboard than the symbols, because I'm struggling to get symbols put in there. And it's one thing that's bothering me. But
On page 231 or 321?
Thank you.
Okay.
Page
I'm
320.
looking at it's like, wait a minute. Something's
It's not
wrong
adding
here.
up, right? Yeah, know how to find the mean of the sample standard or the sampling distribution. Also know how to find the the standard deviation of the sampling distribution. Yeah. And then again, that sometimes that's called standard error. So I might just call that standard error of the mean, which is in that summary. Okay, it's in that summary. And then understand the central limit theorem. That's going to be an open-ended question, right? So look, if we know that our sample's big enough, we know that the average has an approximately normal distribution. I'm going to tell you something so interesting right now that is happening on the North Fork and the Bull Shoals, actually, and it made me think of this section. So the Missouri State University, some guys are coming down and they're doing, one guy is doing his master's thesis on hook studies. So what he's doing is he's having to go through and catch so many fish, and then they're looking at the mortality rate of the fish. So they're using different types of hooks, so barbed and barbless. They're also using the different type, of a J hook or the other two guys. I forget what they're called. I don't usually fish with them. But what he's doing is he has to catch at least 50 fish on each of those hooks and each of the barbs. Now he's doing this. It's the same fish. It's a rainbow trout, and he's doing it at two different locations, on the North Fork River and the White River. But it brings in the idea of the central limit theorem. If he can get 50 of each, they can just assume that it's normally distributed on the mortality rate. Now they're looking more at the proportion, but it was interesting. So I was talking to him yesterday about it, and yes, he is getting to fish for class. That's what he's doing for class right now, is just fishing. And he has to catch a lot of fish. It's neat. They keep him in his live well, in the river, so they're kind of contained in the river, but in an area. And they check them after 5 days to see if they've survived or not. So kind of neat. And so they have to know where they hooked them and what hook they used, and then when they put them in and when they took them out. So it's kind of neat study, but hopefully they'll learn something from it. But anyway, for this class, it had to do with the population of the fish. They felt like 50 was if they can get to 50, they can normally approximate, or they can use the normal distributions on the fish, which is nice. Now your book says 30, but realize if you have the means to go above 30, go above 30. And they felt that they could send Connor out there and fish for 20 more for each one of those types of fish, and it wouldn't be too ineffective, right? Yeah. And then, okay, so for homework on this wasn't a long section. I think the next few aren't long. Oh, we've got the unusual thing too. It pops up. So this is on page 324. It says using the central limit theorem to determine whether a given value of X bar is unusual. Find if X bar is unusual. So now what's different about this is, look, we took a sample. Let's say we did a sample of heights, and we found out that the average height from this sample was 6'3" for males. And so what's different is it's coming from a sample, not from an individual. It's not that an individual is unusual. We want to know if the sample mean was unusual, because that'll happen. I mean, if you find the average of 30 people over and over and over and over again, say you do it for 100 times. Well, remember, if it's if it happens less than 5% of the time, it's considered unusual. So if you take 100 samples of 30 people, you can kind of assume 5 of those will be unusual. Okay, you're just going to get a wonky group that was taller or shorter or something. That's just how it is. But remember, we went over this on the last test when it had dealt with, I think it was an individual data point. If it was unusual because it happened, I think less than 5% of the time. Well, now we want to know, what if we do a sample? How can we determine if it's unusual? That's going to pop back up in chapter 8 as well. Okay, so 7.3. Drop population, mean standard deviation. Yeah. Yes, number 9. So for homework that I would focus on, number 9. Yeah, so percentiles. Number 11. Those are different. If the appropriate, yeah, number 17, because it asks you a good question on 17. Is it appropriate? Working the concepts. But yeah, I like 19 because it's, following are the temperatures in degrees. Consider this to be a population on the population mean and population standard deviation. Ugh, never mind. I lied. Don't like that one. I lied. They look good at first. It's not a horrible question though. There's not one that will work well for this test. Yeah, 21. 21 brings up the unusual concept. Is it unusual? Which just means, is it greater than or will it happen less than 5% of the time? 20. I like 23. And then let's do one more. 29 is a good one. I remember 29. Well, did you have a question from this section, Lori?
No.
Okay. Those are all just good questions. And I'm telling you, I'm going to mimic a lot of these questions and just change the numbers up. That's all I'm going to do. And now, they're part A, B, and C. It'll have to be like, number 1, but then like is the information, and then number 2 will be from the information in number 1, and go about it that way. If that doesn't make sense, let me know. Something on the test doesn't make sense, please let me know.
Okay.
Oh yeah, we did 7.4, right? The central limit theorem for proportions. That was like a really short section. 7.4 was only like 2 pages. And the main thing that's different in 7.4 is the finding the standard deviation of the sample, right? Proportion. So know the summary. I'm going to do that again, page 329. Know the summary, which really just means know how to find the mean and the standard deviation of the sample proportion. Okay, know how to find the mean and the standard deviation of the sample proportion. We know the other stuff, how to compute the probability, because we can get it by using the mean and the standard deviation. So you've got to know how to compute the probabilities. It's on the next page. And it goes over the unusual thing again. We'll see that in the homework. So for homework, though, yeah, like number 9 goes, it's because it's when to use it. When did your book go over that? Yeah, when to use it, not just computing probabilities, know when to use central limit theorem with proportions. And it's on the middle of page 330. So it's in the middle of page 330. where you've got to find like is n times p greater than or equal to 10 and is n times 1 minus p greater than or equal to 10. Then you can use it. And that's like the first part of the homework. So like number 9 is a good example. Number 15. Number 19. That's a good one. And those are good. I mean, these are just 3 good. I can give you more. If you're not grasping these, like say you don't understand 15, look around, do like 15, 17, and do the other ones around it, right? Or go back and look, because there's a lot of examples in 7.4. I'm just kind of pulling 3 out that if you're going to kind of quiz yourself on them, that's what I would do. We didn't do 7.5. And then 7.6 is a little different because I did not give you homework on 7.6, but I need you to know some definitions.
Actually, on 7.6, you told us to do just number 7.
Exactly. I was going to say just number 7. I forgot about that. So know the summary. Page 341, know the summary. I spelled summary wrong. Because, we're going to reject the assumption that population is normally distributed if any of the following occur. So if any of those 3 things occur, we have to reject it. And I know we didn't dig into what those 3 things were per se or how to find them, but know that you've got to reject it if one of those occur. And it is just number 7. That's all it is on the homework. Okay?
Yeah, because you did say that that summary will be on the test.
Yes. Yeah.
Because I wrote "be on test" right next to it.